Hey, everybody. I'm going to give everyone a second here to log in, and then we're going to get started. All right, welcome everyone. Good morning, good afternoon, wherever you're joining us from. Welcome to today's webinar co-hosted by the New York Oracle User Group and Oracle partner Viscosity North America. We've got Oracle Ace Pro Sean Scott presenting for us today. And so I'm expecting to see some great questions coming through. Take advantage of this hour you've got with him. Yes, it's a live webinar. Yes, you're going to get the recording and a slide deck. So I'll repeat that again. Those are the most popular questions. But today's webinar is live, like I said. So look for your Q&A field, not the chat field. If you want to ask Sean questions throughout today's webinar, he'll be monitoring that. So he'll get to your question as he can. But please take advantage of that. If you've got logistical questions or questions about NYOUG or viscosity, you can put those in the general chat for the webinar, and we'll get to you as we can as well. So my name is Monica Lee. Hopefully you guys are familiar with me already. I'm the marketing director here at Viscosity North America, and co-hosting with me is the VP of NYOUG, Coleman Libder. So I'm going to pass this over to Coleman. He's going to tell you a little bit about NYOUG, then I'll tell you a little bit about viscosity, and then we'll get started.
Thanks, Monica, for the kind intro. So New York Oracle Users Group was formed almost 40 years ago. The exchange of ideas, assistance, and support among the users of Oracle software products. We're also always looking for abstracts, and I'll get into that in a second. Connect with us on Twitter, Meetup, and of course the abstracts. Just go to our website, nyoug.org, and you'll see a button there saying request for or submit an abstract. We're also available on LinkedIn, Facebook, and our website again, NYOUG. And we want to thank Viscosity North America for co-hosting these series of webinars that's been going on for, I understand, 3 years already, and will continue to do so. So thank you, Monica.
Thank you so much, Coleman. And I know a lot of you are probably familiar with my little pitch here, so I'm going to make it quick so we can get to the good stuff. All right. So like I said, I'm the marketing director here at Viscosity North America. Hopefully I've met some of you guys at conferences around the country. We actually will be at NYOUG next week, which is in Denver. Sean will be there, as well as other team members of ours. And then after that, we'll be in Salt Lake City for UTUG's training day. So if you're in those areas, I hope you check them out and register. They are still open for registration, and I'll send you guys some links to that later too, just to remind you. All right, so here at Viscosity, it's our mission to enable business transformation at a time when companies must change to survive. We are a full Oracle stack consulting firm with core expertise in Oracle database, including RAC, Oracle Apex. We perform near zero downtime migrations, performance tuning, and high availability projects. So we've also got decades of experience with infrastructure, including engineered systems, and we offer project-based services as well as managed services and training. So if you see across the bottom under our 3 main pillars, we provide proofs of concepts, workshops, assessments, things like this across our 3 pillars, which are data, apps, and cloud. So if any of these resonate with you.
Monica, you're not sharing your screen.
Oh no, really?
Really?
Oh no, it says stop.
Or I just got black on mine.
Yeah, here too.
Resume share. If anything, I'll just let you guys listen to me. Let me stop it and restart it. How about this?
Oh, there we go.
All right, so it's okay. You've not missed much. So these are the 3 pillars I've talked about across the bottom. Again, items we offer throughout all 3 pillars. All right, this page just features some of our Oracle aces. These folks are our consultants and also executive management, and they're thought leaders throughout the Oracle database and development community. These folks present all around the world on Oracle topics. They write blogs, books, case studies, anything to continue helping the Oracle users community and Oracle customers like you. So thanks to Sean Scott and all the other aces out there that kind of keep us going and keep us up to date on Oracle tech. All right, so on this page, we've got different services, but the one I always like to highlight is Oracle License Management. We do resale for hardware and software, and we've got several people on our team who actually came from Oracle specifically in license management. So we do really strive to make sure you guys are taken care of and that you're only buying what you need to buy. Also that you're getting the best rates possible. So I highly recommend working with any partner really, whether it's viscosity or not, just to make sure that you guys are doing exactly what you need to do, no more, no less, with Oracle licensing. And then here we've got some of our books. We've got recent books that just came out. Oracle on Docker just came out from Sean, today's presenter on today's topic. So lucky y'all, go check it out. I know it's on sale at Amazon if you're interested, and other books here that may interest you. Oracle Database Performance Tuning and Upgrading Oracle Databases also just came out. Others here are some of our featured bestsellers as well. And as of January of last year, AuraPub is now powered by Viscosity. If you're not familiar with AuraPub, it is created by former Oracle employee and AuraPub owner, Craig Shallyhammer, and it's got tons of training. It's where we actually house all of our webinars like this now, including slide decks, as well as things that these guys may present at different conferences. So I highly recommend going there and at least signing up for a free membership. It's just got a huge database full of content. All right, and I swear, I think this is my last slide. No, I'm just kidding. Second to the last slide. Here's just where you can find all that stuff again. And keep up with events at events.viscosityna.com. And you can follow us. And I will now turn it back over to Coleman.
Thanks, Monica. So let's introduce Sean as a managing consultant at Viscosity North America, working at the intersection of database and systems reliability, database management, and DevOps. He's a subject matter expert on Oracle database high availability, scalability, upgrades, and migrations. Leveraging nearly 30 years of experience as a database administrator and engineer, he designs resilient and flexible database solutions, develops database and infrastructure automation, leads modernization and migration projects, and coaches teams on their journeys towards DevOps. Sean's an Oracle ACE Pro and Oracle Certified Professional, a featured speaker at user group conferences and events worldwide, and the author of an upcoming A-Press book on running Oracle databases on Docker. And thanks Viscosity North America for co-hosting these series with us. And Sean, we're great to have you here and look forward to your presentation.
Great. Thank you very much, Coleman, for the introduction and for the New York Oracle User Group for hosting us here today so that I can talk to you about running Oracle databases in containers. I see there's one question already in the Q&A. Is there somewhere beside Amazon where you can buy the Oracle on Docker book? It's out of stock on Amazon. Yes, you can go to the A-Press site, and A-Press has it as a digital download where you can download it. Okay, so let's jump into the presentation. Again, running Oracle databases in containers. This is me. I think that Coleman covered all of the myriad things that I've gotten involved in over the last 28 or 30 years, however long it's been since the last century. I did just write a book. It was published yesterday, I found out, through A-Press. And it is available on Amazon. It's on Barnes & Noble. And as I said, it's on the A-Press site. If you would like to download a sample chapter, there's a chapter there on persistence available on my blog site, which is oraclesean.com. So let's talk about Oracle and Docker. I started out with Oracle and Docker about, 9 years ago now. And I was working for a company, we were an e-commerce company, and I was asked to build some databases out on Docker. I didn't know anything about Docker, I'd never heard of it before. It was still a relatively new technology. I had no idea where to start. So I reached out to some folks that I respected in the Oracle space and did some reading. And I learned something very, very important. And that was, don't use Docker for databases. Everything that I read, everything that everybody told me was just this, they were horror stories. And so I went back to my boss and I said, this is an awful idea. And I offered him alternatives. I suggested that we do different things. I begged with him not to make me do this thing. And he's unsympathetic. He says, well, it's not really my call. It's the CTO's call. The devs went to him and said that this is what they need. He came to me and said, make this happen. And he went to me and said, this is your job. So I started doing the work. I was convinced it was going to be a huge disaster. And I even started preparing all of my I told you so's to share when everything blew up. And then a really funny thing happened. It turns out that it actually works pretty well. And I realized there are a lot of myths in the container world, or at least in the database world, relevant to containers. And some of them are here. So containers are for developers, not production. Containers can't or shouldn't support complex applications like Oracle. This is one of my favorites. Containers are ephemeral, meaning they're temporary, and they can't be trusted with your important data. But the more I heard all of these things, and the more tragic all these horror stories were, the more I realized that this was kind of like when you watch one of those infomercials and they have a solution for something, and it's just the most unreal sort of problem that you'll ever face. And all these complaints were coming from people who really didn't know much about Docker at all. And then I started to realize they sounded a lot like a lot of the other stories about other technologies that I'd heard over my career. So for example, when RMAN came out, and yes, I was there when RMAN came out, people said, oh, no, I've got 7,000 lines of shell script that does all of my backups for me. So that's never going to replace this RMAN thing. I won't get real backups from that. And then we started seeing the advisors and automation coming out in the database, and DBAs were saying, oh, no, we can't automatically tune memory. We can't assign rollback segments or undo better than a real DBA through some sort of automation. I vaguely remember tuning rollback. I probably couldn't do it now if I tried. Saw the same thing with virtual machines. VMs started growing in popularity, and a lot of people were saying, no, you should never run a database on a virtual machine if you want to have any sort of performance. Same thing with the cloud. No, we can't do anything in the cloud. It's just a fad. It's another way of marketing somebody else's data center. So a lot of these things have this very familiar ring. It's a new technology, it's change, and people are afraid of change. So the official word from Oracle, which you can find here in their MOS document 221.6342.1, is that Docker is supported for running Oracle databases in production. And even as of last year, Marcus, this was October 2021, so a little over a year and a half ago, Marcus announced that RAC on Docker is supported on Red Hat Linux with version 21 and later. So we can use production or use Docker for production environments. It is completely supported by Oracle. There's no reason that you can't use it. It's just a different technology. It's a different way of doing things. And there are some things about Docker that make it unique that we have to manage a little bit differently. But it is a very powerful and robust platform for running databases. There's one other thing that I want to address, and this is something that I hear people say, database administrators say, as a reason why they can't do a lot of things, but it applies to Docker as well. And that is this idea that databases is special, or databases are special. And databases aren't special. Data is special. So your database environment is part software, it's part the database configuration, and it's part data. This is not a database. The whole thing isn't your database. This is the database, the configuration and the data. And what containers do is they do an excellent job of separating the software, the part that isn't the database, into something called an image, and letting us persist all of the other information, the configuration and the data separately. And that configuration includes things like your SQLnet and tnsnames.ora files, your SP file, your password file, and so on and so forth. And we'll talk a little bit later about how Docker or containers in general do that. First, though, I want to talk about why we would want to do this. What are some of the reasons that we would want to run a database in a Docker container? And there are a lot of reasons, but first and foremost is that images, and I'll get into the definitions of some of these terms in just a second here, but images are something called infrastructure as code, which means that we write some instructions, some scripts that generate all of our artifacts or assets that we will use in our Docker environment. And with those scripts, they're code, so we can put them into a version control system, which means that everything that we do with those systems is extremely reliable and highly repeatable. And that's something that we want to have in our systems. So if you think about it, if I've got a data guard environment in a Docker containers, and I test my failover and my switchover and processes, I want to know that those same procedures are going to work exactly the same way in my production environment. And this is where something like version control and infrastructure as code helps us, because if we have the exact same software deployment in all of our environments, separate from the data, but the exact same software environment everywhere, then I know that the rules of the game in one environment will play exactly the same way in another environment. And when we build images through this code, we get what's called an artifact, sometimes called an asset. And those artifacts are portable, and we can distribute them. We can put them into repositories. And the really cool thing about Docker that distinguishes it from a lot of other solutions is that if I build an image on my machine, and I'm using a Mac, the image that I have, I can share it with someone running Windows, running Linux. It will work for them. It will work in Docker. It will work in Podman. It will work in Docker Compose, Kubernetes. It will work in Oracle Cloud, Azure, AWS, Google Cloud, any platform that supports the standards that the container standards, which are also confusingly called OCI, the something container initiative. I can't remember what the O stands for now. All I've got is Oracle stuck in my head. But that container initiative standardizes the container construction and deployment and so forth. So my images will work pretty much anywhere. And there are a lot of things that we can use this for. We can use containers first to eliminate dependencies. So if I'm running on a Mac, I can't go and download Oracle 19c for Mac. Maybe I don't want to write scripts on a Windows machine for testing that I would have to rewrite in a Linux environment. So I have this nice non-dependent environment that's going to work across every platform that I work in. But I can also do my development there. I can hack at things. I can practice for exams. I can actually even do performance tuning. So on my laptop with no data, I can import statistics from a gigantic production database into an environment on my desktop or a laptop machine and do some, not all, performance tuning based on those statistics. I can do a lot of testing without infrastructure. I can validate how I install patches and perform upgrades, do labs and training environments, all sorts of different things. Hey, why wasn't Ernie bouncing around and giving the thumbs up there? I like to use GIFs. And there are all sorts of things that are possible. So everything from a vanilla database all the way through DataGuard, FarSync, RAC, sharding, and so forth. I do a lot of upgrades and upgrade testing, and probably a year or so ago, I was working with the auto upgrade team. We ran into a problem with the auto upgrade software, and it was very difficult to duplicate. So it's something that failed partway through the upgrade. And I was on a screen share with them, pulled up my upgrade environment, walked through so they could see exactly where and how the problem was occurring. And they said, okay, great. We need you to make a couple of changes to your upgrade process. So you're going to restore your environment and all this stuff. And let's get back on a chat in a few hours or tomorrow. And I said, oh no, it's going to take me 30 seconds to do that. And just the nature of how Oracle on Docker works, I just restored my data set and started over from the point of failure, which fascinated the Oracle team. So lots and lots of cool things that you can do with Docker and Oracle. But really the neat thing is how fast it is. And I can tell you something's fast the way that I can tell you the Grand Canyon is big. And until you see it, you don't really appreciate it. So here's what I'm going to do. I am on an Oracle Cloud free tier instance here, and I'm going to run a Docker command. And you see here it says Docker run. This -IT means I want to set up an interactive session. It's interactive TTY. And I'm going to just start an Ubuntu container. So I don't have Ubuntu on this machine. I don't have the image available to me. So what's going to happen when I hit enter? Docker is going to go out. It's going to download that Ubuntu image from the Docker Hub for me, and then it's going to run it. And you'll see, whoops, there we go. That's the problem with live demos. There we go. So it couldn't find it locally. It's going to pull my image, and boom, there we go. I am now in an Ubuntu Linux container. That's if I didn't have the image. If I exit out of that image and I run another container, I create another container from scratch with the image already on my machine, watch how fast it is. Boom, there's no boot cycle or anything. But what I really want to show you, and this one's probably going to fail, it's probably disconnected also because I set this up a little while ago. Yep, there we go. Okay. So here's what I'm going to do. If you see here, I have a bunch of, these are all containers on my system. And this one in particular is the one that I'm going to stop. I created this for another conference a few months ago. So I am going to run this long, ugly command here. And it's actually going to do 4 different things. It's going to stop this container, which you could see was running. Well, it's going to stop it twice. Then it's going to start it. And then it's going to tail my log. So I'll see my alert log running once it starts. So this is an Oracle database. This is a real Oracle database that's running here. It'll take it a second to stop the running container. Then it's going to give me an error because I put that Docker stop in there twice. And then once it starts that container, there's my alert log. It started the listener. It's starting the database. This is how quickly we get an Oracle database up and running in a Docker environment. That's all that it took. I didn't have to boot a VM, nothing like that. So it is extremely fast and really fun to play with. So what exactly is a container? And one of the things that I hear people say all the time, this is a really common thing that explanation that people give, is that containers are like lightweight virtual machines, and they are not. It drives me nuts when I hear people say that, because there's really very little or almost nothing that they have in common. So I want to step away from the container virtual machine thing for just a second and talk to you about something that you may already be familiar with, and that's this idea of an Oracle database. And here we've got an Oracle database. We've got a single Oracle home, and we're supporting 3 different applications with 3 different databases. And there's a lot of weight here. When you say I've got duplicated metadata, I've got all my standard processes are all there for each database, then I've got memory assignment, and then I've got schemas. I could also do it like this. I could just have one database in one Oracle home, and I could just have 3 schemas, or I could have 3 pluggable databases. So 2 different ways of getting the same thing. One is obviously going to be a lot easier on resources. I don't need as much capacity for this example on the right-hand side. Well, the comparison between virtual machines and containers is very much the same. So here on the left-hand side, we have the equivalent of the 3 database solution where I've got my host operating system. I've got a hypervisor that performs the abstraction and all of the interpretation for my guest operating systems and each of my guests. It allows them to talk to my host resources. And then on top of that guest operating system, I've got any specific application specific binaries and libraries and code and so forth sitting on top of it. On the right-hand side is what containers do. And we still have the host operating system. There is a container runtime, which is much thinner and far more transparent than what you see in a hypervisor. But I don't have any guest operating system because containers use resources from the host operating system. They interact directly with it because each of these things that you see here on the right-hand side, each of these applications is a single process on my host. All I need are the unique binaries and libraries and so forth that are necessary for that application. And if you look at the height of these different stacks, you'll notice, well, I've got a lot more room left over on the container side, so I could pack more containers into that same space. And containers are exceptionally efficient in ways that you would not expect. So how efficient? Has anyone here run more than one Oracle database on a laptop using VirtualBox? 2, 3, 4, maybe? How about 13? And this is just, I happened to have this and thought, oh, gee, how many can I actually run? So I had 13 Oracle databases up and running on 2018 MacBook Pro with 16 gig of memory. There's no way that I could have gotten away with that with VirtualBox on the same machine. It would have dragged it to its knees. I think the most I've ever had were maybe three VMs running. So they are exceptionally efficient systems. And containers have been around for years, much, much longer than Docker. All that Docker did was build an API on top of a set of Linux commands that make the process of building and running and managing all of your container processes much, much easier. So in a sense, Docker is sort of the Red Hat model here. They took a business model out of standardizing and simplifying a technology and then monetize that. So the container virtual machine comparison. Virtual machines are a bootable operating system. They're often very heavy, and you could think of them as like a game book, a 100-page book of games and puzzles. So I've got lots and lots of different games in here that I could play, whereas a container is something that supports just a single application or service. It's very dedicated, very specific, and you could think of it like a single sheet of paper that we use for playing a game of tic-tac-toe. All right, I've been talking about containers and images and so on and so forth. Let's talk about some of the vocabulary. And first, I'm going to answer a couple of questions here that I've got in the Q&A. The first is there an additional license cost? No, there's no difference between running this in a container versus running it on bare metal or a VM, the same licensing. There's no added cost there. I am not a licensing expert, so don't just go out and start running all your production in containers and say, I don't have to pay extra money or something. And then the second question is, does Oracle Cloud have an install that includes Docker, or do you need to download and install it? You would have to download and install it. And we'll get to that. I'll show you some examples of that in just a few moments here. So I've been talking about containers and images. Let's get into some of the vocabulary so that we're speaking the same language here. And there's probably 3 terms, maybe 2 terms that are really, really important for you to understand the difference between, and that's image and container. But there's some other terminology here that is helpful to understand. One of them is layers, which marries with this concept of a union file system. And then we get into things like stateful and stateless, immutable, ephemeral, and persistent. These are all properties of containers and images. So I'm going to try and keep this really simple for you. An image is just a file system and some metadata. It is literally a tar file that is a set of directories and files. That's it. And then there's some JSON metadata that goes along with it that are the instructions that Docker uses to run that code, that file system, as a service. And pretty much everything that we do in Docker, you can think of as a service. And a database is a service. It is a black box where we send SQL requests, queries, and so forth, and we get a response back. And that is pretty much the definition of a service. It is something that does something for us. We tend to, as database administrators, think of databases as our databases as much more complex and I don't know, opaque than that. But really, it's an application. Our database is an application that manipulates data for us. It does it very well if you're talking about Oracle or pretty much any other database vendor. But this is what an image is. It's a file system and it's some metadata, and it does a thing for us. Now, those file systems that are in our images are constructed in layers. And this is really cool when you get into it. So what do I mean by constructed in layers? Well, if I take a database image, if I want to build an Oracle database, whether I'm doing it in a container or I'm going to do it on a bare metal machine, I'm going to start out by installing Oracle Linux 7 or Oracle Linux 8. And then on top of that, I'm going to install the pre-install RPM, and then I'm going to add my database binary. Well, this is where we depart in a container world from the bare metal or virtual machine world. In a bare metal virtual machine world, we have libraries and so forth that are part of Oracle Linux 7. And when we do that pre-install RPM, it changes. And so we've got one kind of layer of silly putty that we're just poking at and changing and sculpting to our needs. Well, with containers, that Oracle Linux 7 layer, we create it and it never changes. We put the pre-install RPM and the binary on top of that as another layer. And it becomes the additive, kind of the sum of those two things. And that's how we construct our images. And I'll show you in just a minute how that is really useful to us and lends towards some of the efficiency I was mentioning before. And that is that these layers in our images are modular and they are reusable. So what do I mean by that? Well, I have that Oracle Linux 7 layer that I start out with, and then I add my pre-install RPM and my binary. Okay, now I've got a 19.3 Oracle database, right? But what if I wanted to have a 19.15 database? Well, I would install the 19.15 release update on top of that. Well, that's a layer. Well, what if I also want a 19.16? Well, that's a layer too, but those two layers sit on top of the same underlying structure. So I'm not recreating any of this. I'm just building. It's almost like we're using Lego bricks to put something together. Okay, well, 19.15 to 19.15.1, it's another layer on top. 19.15.2, another layer on top. 16.1, another layer. 16.2, another layer. So all four of these images that you see at the top, 1915.1.2, 16.1.2, they all use the 19C pre-install RPM and 19.3 database binary and Oracle Linux 7 layer. They all share that, which is why they are so efficient and so conservative on space. Okay, so that's our peek into images. Let's talk about containers. Well, when we run an image, it starts a container. And part of that is it starts an isolated process on the host. So behind the scenes, containers doing chroot and manipulating our C groups and so forth, so that that process that the container that our database is running in is invisible. It's isolated, partitioned away from everything else on the system. So it's protected. And this goes way, way back to network time sharing, back to the 70s, where we wanted a timeshare on huge, expensive database or processing platforms and be able to host competitors on it and be able to assure them that people couldn't peek into their neighbors' information. So when we run an image, it starts a container, creates a process for that container. And physically, what we get is that image. And then we create a very, very thin layer that we superimpose on top of it. And I like to think of those layers as a sheet of glass, and it starts out transparent. So here I've got a tic-tac-toe game, and it looks like a tic-tac-toe game, doesn't it? We see the grid there. And I can start playing tic-tac-toe, but I'm not really playing tic-tac-toe in the image. That's the image. The grid is the image. That sheet of glass sitting on top of it, that's the container. And so I take that piece of glass away, the image underneath it completely unchanged. I break that piece of glass, my container goes away, but my image is preserved. I can start and stop my container. It's just that piece of glass is where all of the activity is happening. So we can kind of think of it like this. An image is the game board, and it's a set of rules that tell us how to play the game. The container is where we're hosting the game, where we persist all the moves that the players make in the game. And that superimposed layer, that thin sheet of glass or clear plastic, whatever you want to call it, that's where the moves go. And when we delete a container, all that we're doing is throwing away or smashing that piece of glass, that thin overlay or superimposed layer where the moves are taking place. So multiple containers, we can share a single image from multiple containers. When we looked at this before, we saw that idea of the host operating system. We had the runtime, we had some applications running on top of it. And let's say each of these applications, it's the same application, it's 500 meg, right? So 500 meg times 3, well, that's 1500 meg. I should need 1500 meg on my machine for this. Yes? No. No, it's 500 meg, because this is the same image used by 3 different containers. It's using the same underlying image layer. All that is different between these 3 containers is that very thin container layer on top. Okay, let's talk about some properties of images. And the first is that images are immutable. We can never change an image once it's created. Okay, why is that important? Well, let's go back to our game. We'll play a game of tic-tac-toe here. And we get to this point, oh my goodness, we have a stalemate in this game. Nobody wins. But what if I were to change the image behind this container? And I shifted that game board to the right, just a touch, just like that. Well, now all these moves in that left column, they fell off my game board. And if I resume the game, well, now there's no stalemate. The O's can't lose this game. So changing an image changes the game, which means that any running container that I have in my environment would start behaving differently. And that's why it's really important that we can't change images. And since we can't change the image, we can't save state to them. So we say that they're stateless. But containers, they are stateful. They have that thin glass layer where we're persisting all of the runtime information, all the state information. And again, if we delete a container, it removes that runtime layer, meaning they're ephemeral. And that is a phrase that frightens a lot of people in the database world because they think, oh no, I'm going to lose my data. And it's the foundation of one of the myths that I discussed a little bit earlier. We'll talk about this in just a second here. So very briefly, images are static. We think of them more as templates or the seed PDB in a pluggable database, where containers are living, active assets on our system. We can think of them more as documents or the pluggable databases that we use. All right, and with that, let's run Oracle on Docker. I know, it's about time, huh? Okay, someone had asked earlier about, is there install that includes Docker? Do you need to download and install it? And then Ahmed here asked how to create a Docker image from a VM. That is a somewhat more complex question. I'll address that I'll address that at the end. If you don't. Running that many containers, how does Docker manage the SGA and PGA? It's actually shared memory on the system. So if you had really active containers and they were consuming a lot of RAM on the system, then yeah, they would, but they don't reserve it in the same way that VMs do. So we get away with that. Host OS still needs to have shared memory configured appropriately to allow for running Oracle DBMS inside containers. Yes, yeah, the host system does need to have some compatibility, which is why when you look at Oracle's documentation for running Oracle databases in production on containers, they say we want it running on Oracle Enterprise Linux 7, 8. They have some requirements for it. And that's just so that everything on the underside beneath that runtime layer is running correctly. All right, so let's talk about running Oracle, or building images rather. So the first thing we need to have is that image. It's the rules for playing our game of Oracle database, right? So the first thing we want to do is we want to download, if we're going to do this on our desktop system, we'll download Docker Desktop. On Linux, you go out and you get the Docker engine. There is a Docker Desktop for Linux, but it's probably easier to do it with the Docker engine. If you're running on Linux, shoot me an email or reach out to me afterward, because there are a few things that are a little subtly different for Linux systems. So we've got our Docker software available to us. We need to download two more things. And the first is, if we're going to build a 19C database, we're going to go out to Oracle's website and we're going to download this Linux x86-64 zip file. Even if you're running Windows, even if you're running Mac, we're always going to go out and get the Linux version of Oracle. And that's because we're going to be running it in a Linux file system. And then you want to go out to this GitHub repo that Oracle maintains. This is Oracle's official Docker repository, container repository. And you will pull or copy this set of files and scripts and so forth. This is the infrastructure as code part of things. So you can download it, you can Git clone it. There's no difference between whether you download a zip file or clone the repository. You get the same thing if you're not familiar with Git. And that is going to create a directory on your system. And you are going to copy that downloaded file, that zip file that you created, into this nice long directory. Excuse me for just a second. Working at home, I don't talk that much. So we want to download that file into this, this long directory. You end up with this 19.3.0. You'll see that there are some subdirectories there. This is where we're going to put that zip file, and we do not unzip that directory or that file. We're just going to leave it as a zip file. Docker is going to take care of that for us. And then if we navigate just one directory back into this Docker files directory, you'll see that there's a file there called build container image.sh. And if you run this script, it does everything for you. We're just going to supply a couple of flags. The first is that's -v flag that says I want version 19.3.0. And the -e says I want enterprise edition. There's also a -s for standard. And for some builds, there is -x for XE, for Express. And when you run that script, then we wait a couple of minutes. Builds for me take anywhere between 7 and 15 minutes, depends on the machine. But what this is doing is it's going to go out, it's going to install the database software for us. It's going to create that file system structure, run the root.sh scripts, everything. And when we're done, we'll have the image that is a complete file system, everything that we need to run an Oracle database. If you do not want to build, you can also go to Oracle's container registry and you can pull images. As of right now, I believe there's a 21C, a 19.3, a 12.2, and a 12.1 enterprise edition images out there. They are not super robust. They are not, you don't have as much flexibility to configure them. They're very basic images. So they're not the type of thing that you would take into a production environment. They're more there for developers to download and play with. This is a quick and easy way of doing things. I personally prefer, and I would recommend that you build those files yourself. One thing I will caution you of, though, is that if you go out to Docker Hub, and it's hub.docker.com, this is where, when I did the Docker run Ubuntu earlier, Docker went out to the Docker Hub and it pulled that Ubuntu image down for me. That's where it found it. Well, the Docker Hub is a little bit Wild West because anybody can go out there and they can upload things to the Docker Hub. And you can search the Docker Hub also. And you may find Oracle images out there. Well, first, anyone that's distributing an Oracle image on Docker Hub, again, not a licensing expert, but you're probably in violation of Oracle's licensing. It is also a massive security risk. If you're running an image on a container, you are inviting them to run malware on your machine if you are not confident in the source of that software. So be very careful and cautious about what you download and run on your machine. All right, so now we have an image. We've built our image. This is the rules and so forth that we use to play our game of Oracle database. And this is all you need to do to get an Oracle database running. I'm going to walk through this command for you real quickly. The first is Docker run. Most everything that you see in the Docker world begins with Docker. Even Podman commands will interpret Docker and understand them as Podman commands. So Docker, and then there's a verb that comes after it, Docker run, Docker build, and so forth. Here we're going to run something. We've got this -d, which says I want to run something in detached mode. I want to run it in the background. I want to set this up as a background process. Remember, we had the -it earlier that got us the interactive. -d runs in the background for us. And then this is what we're going to run. This is the image that we're going to run. And this is what your image will be named after you have built an Oracle image from the repo scripts that I showed you just a moment ago. And this will run a database for you, but you don't want this command. You really want something a little bit more complete. So this is a better example, a more useful example of running a database in a container. We've got that same Docker run -d command, but now we've got this --name. --name means I want to give this a container a name so that I can reference it easily. If I don't give it a name, Docker assigns a name to it for me that looks something like this: unruffled easily. It makes these things up. And there's another one up here, optimistic Nash. So it generates these names for us. It's better to give it a name. So here we've got a name. Then I've got this -p command where I'm saying I want to map a port. The second half of this, the 1521, looks familiar, doesn't it? That is the port in the container. I'm going to map that to an open port on my host, in this case, 51521. So that's just the port where my database listener is going to appear on my host. So instead of connecting to my database over 1521 from my local host, I'll connect to it at 51521. And then this command says -v, I want to assign a volume. And just like the other, or the port command before it, the second half, the /opt/oracle/oradata, what do you think is there? That is where all of my data is. And the first half of this, everything before the colon, is where I'm going to map that data. Now, remember before we were talking and saying, well, when I delete the container, everything in the container would poof, vanish. This, mapping it to a volume, puts the data on my local system. It's not in the container anymore. So even if I delete this container, all of the data that I've generated is persisted to my local storage. So it lives outside of the container. And this is sort of what I was mentioning before, that the data and the configuration is the database, not the software. I'll show you a little bit more on this in just a second. Then I have this -e that says I want to set an environment variable of Oracle SID to 0193. So now I'm naming my database. I tell it this is the Oracle SID that I want. And then I've got the container name. There are a handful of different environment variables that we can set. So you can set the password, the Oracle SID, the pluggable database name, the character set, and so on and so forth. There's a lot more that you can do with this Oracle run, or I'm sorry, this Docker run command than just this. But that will start a container for you. And if you want to log into the container, you use this command, docker exec. Again, Docker followed by some verb. Here we've got this -it. I want an interactive connection to my container called 0193, which is what we said in the name. And then I'm telling it what I want it to run. I want it to run the bash shell command. So when I do this, it'll drop me into a container and I'll get a bash prompt. It'll look like I've SSH'd into a brand new system. If I wanted to connect to this environment from SQL Developer, I would connect to the local host on that mapped port 51521 and just give it the Oracle SID or the service name, just as you would connect to any normal database, because this is a normal database. All right, let's talk about that data volume. So if I were to log into an Oracle database container and navigate to that /opt/oracle/oradata directory and list the files, I would see this. I would see that I have what looks like a totally normal Oracle database here with my database SID and my pluggable database name, and then control files and my seed database and redo logs and all of that. Everything over here on the left-hand side, totally normal looking. See it in any Oracle database. But the stuff over on the right, you would not normally see that. Here I've got a completely different directory called dbconfig, and then I've got a subdirectory for my Oracle SID. And here's my listener.ora, my password file, my Aura tab, my SQLnet, my TNS names files, all of the configuration. Why are they here? Shouldn't they be under the Oracle Home or in the TNS admin directory or in Etsy? these files don't normally appear here, do they? Well, in a container, what happens when it starts up, it goes out and it says, hey, you asked me to start. I'm going to look and see if I already have a database. And it looks into the volume, if we've created a volume, and it looks for this DB config directory. And if it finds all of this configuration information, it's like, oh, hey, cool, I already have a database. I will start it. If it doesn't find that, well, it creates a brand new database for us. And then it moves all of those files into this DB config directory. And remember earlier, I said your database is your configuration and your data. Well, this Aura data directory is your database. So when I run this command and I map that data volume to some directory on my local machine, I'm saving my entire database on my local machine. They're all of those files, everything that I need for my database is in this Aura data /0193, whatever directory you set, which means that after I've freshly created a database, I've got a gold image of a database in that directory. My data files, temp, redo log, archive logs, all my configuration files, everything is there, which means that I could copy that directory to another directory. Let's call it clone. And on Linux systems, you have to do this little extra step where you change the ownership. If you're on a Mac or Windows machine, you don't have to worry about this. But now I've got this directory called clone, right? And if I start a brand new container, give it a different name, change the port number, because I can't have two containers running on the same port, change the location of my data volume, I need to have the same Oracle SID. Well, it's just going to start that database for me because it looks in that directory and it says, oh, look, I already have a database. I don't need to create one. So if you need to create QA environments, or if you need to revert back to a known good state for testing, anything like that, this is like magic for you. I cannot tell you how useful this is as a technology. One thing I would mention, use unique paths. I learned this the hard way because if you put all of your databases into a single directory, just like Aura data, you have a bunch of databases running there. Oh, well, now it's a bunch of database files all commingled in the same directory, which it's not a good look. What you get from Oracle's build is a very generic database, but you can go in and do all sorts of things. So if you go into this subdirectory that is the version in that Oracle repo, you'll see several different files there, a Docker file, but primarily the setup linux.sh, install DB binaries, and all these sh files are just shell scripts. And so you can go in, and if you're comfortable with your shell scripting, you can go in and manipulate those scripts to get different results. You can go into the db_inst.rsp, that's your database installation response file. So you can change things in the response file, and you can go into the dbca.rsp.tmp, that is your database configuration assistant response file. And by making changes there, you can change how your database builds and creates and so forth. So you've got all sorts of different ways of reconfiguring things. So let me look at some questions here. Does Oracle on Docker work with single instance file system based DB? How about RAC and ASM and Oracle Restart and ASM? Yes, you can run Oracle RAC with ASM and Restart. That is part of the RAC build, which if you look at this directory structure that you see here for the build scripts, it's Oracle database / single instance. There's a subdirectory for RAC. So you would just follow the instructions there. And Oracle does a wonderful job of documenting all of this, all of these builds and so forth for you. I believe Oracle XE is the edition to use without a license. Yes, that is correct. You can use XE without a license. There are XE is the version that is the exception to the rule where you can download it. Excuse me, where you can download it, because you can, well, I don't want to say that definitively, but I don't think that you have to have a license to redistribute the XE version. Is it possible to run rack using Docker? Yes, as of 21C, rack is supported for production. For 19C, rack is supported for non-production environments. Do you use the -E option to set everything that would normally be sourced in your Oracle instance environment file when you instantiate the container, so that everything is set for you to interact with the instance in a Docker interactive session? You do not actually need to do that. The only thing that you would need to set would be the Oracle SID, if you want to change that, the password, the pluggable database name, things that might affect the database creation. Everything else, however, is going to be there for you. It's natively part of the Docker image. So you don't need to go in and set like path and Oracle home and things like that. That's not necessary for you. I hope that was the question you were asking there, Joseph. Containers separate configurations and data from the software. Config and data are in the image. Software binaries are not in the image. The opposite. So the config, the binaries are part of the image. The image is like the rules of the game and the playing field. So the image is going to have our Oracle database software. The container has that container layer where all of the state information is persisted. And that is where our database is going to be, unless we put the database onto a volume. And when we put that Aura data directory into a volume, we're taking it out of the container and putting it onto our local machine so that we have some persistence, so that we can use native high performance storage for it as well. In fact, the free download chapter from my book is on persistence. And so if you want, excuse me, if you want to go to oraclesean.com, download that chapter on persistence, that has information on how that whole persistence occurs and how you can use that to access different types of storage. Gives you a little bit more detail into the whole persistence element. But the image has the software binaries, the container will have the configuration. How will it work to install Apex on the DB as part of the image? It works actually really well. You can do it a couple different ways. One is that you can create an image with Apex and then run an Apex container and a database container and let the Apex container talk to the database container. Or you can build an image that you install Apex into, and you have a database slash container or a database slash Apex image. If you would like, shoot me an email and I can talk to you a little bit more in depth later about how you might go about that, because there are some considerations for building images, more complex images like that, how you would install Apex and so forth. But feel free to reach out to me separately. What about performance? If this was a QA instance, currently a VM with foreign application connections, how would Docker perform? How does Docker impact tuning? So this is a question that comes up a lot about performance. If I have a machine that has X horsepower and I'm running a VM on it, and then I have another machine that has the same amount of horsepower and I run Docker on it, I'm using the same horsepower. There's no loss. In fact, it's arguable that the Docker version will run faster than the VM version, because that virtualization layer that you get in there is going to sap some performance away, because it's doing some interaction. It's saying, okay, now I've got to translate this to my storage subsystem, to my network subsystem, and so forth. Whereas the Docker container is running directly on the host system, if that makes sense. it's interesting. It's all that we're really doing with a container is we're sort of taking all of the processes that we would run by having a native Oracle database running on a system, and we're just putting it into a container, we're compartmentalizing it, isolating it. And you might say, oh, well, then what's the point of doing this? Well, the point of doing this is that if I want to upgrade my database, if my data is separate from my database software, I stop my database, I remove the container, I start a new container with my new Oracle database version software installed on it, I point it at my data. When it starts, it sees the database. I run db patch, and now I have a new database version. I'm not upgrading software. I'm not changing my software on the fly. So I have an image that it is a gold image of, let's say, a 19.11 database. I have a gold image of a 19.14 database. Those images are portable. I can modularly move them around, point them at databases, and I'm assured that I always have the exact same thing. Whereas if I go out and I take a 1911 database and I upgrade it to 19.14, it's kind of that, well, I'm going in and I'm removing files and I'm adding files and I'm changing files and sort of molding and sculpting that environment. And maybe you've got something that's reproducible. It's going to be identical between your systems. But if I run the same image in every environment, I know it's exactly the same. How is the persistent storage created? Excellent question. It is created when we run the container. So, oops, wrong way. Wrong way. So it's created here when we create, oops, that's not what we wanted. It's created here when we create the container. So this is the only opportunity that you have to set the networking and set the storage is when I run this -v command. So that's where I'm creating that, I create that persistent storage. How is data persistence addressed? We save that information on a local file system. So let me take a look here real quickly. And I'll show you. So these are all Oracle databases that I have running. This is where their data is. So if I go to this, you'll see I've got subdirectories for my audit data, and my diagnostic directory. Oops. Yeah. Permissions. So this is where I'm persisting my data, and I could persist this onto an NFS volume, onto local storage, onto any high performance storage that I wanted to. So this is where I'm putting it. I'm persisting it onto a local file system. Does OEM support monitoring of Oracle RAC on Docker? OEM would not know that it is running on Docker. All that it would see is that it's an Oracle database. So absolutely, yes. Was a physical production server typically host only one Oracle container? Probably. I've worked in some environments where we run multiple Oracle databases on a single production host. They're not high volume, super busy systems, anything like that, where you're using a lot of memory, a lot of processing power. So you can certainly do it, but typically, yeah, you would pretty much the same thing you would have in a VM environment. You wouldn't run necessarily a bunch of VMs with Oracle databases in them. If you do, you could do the same thing with Oracle containers. If you have the capacity, it's just a capacity question. Will this work with ASM? Yes, it does. Are you able to run an image in Kubernetes cluster? Would you recommend it? Yeah, there are. Would you recommend it? I'll answer that in two parts. You can, absolutely. There are Kubernetes operators for running Oracle databases. Google has one, and Oracle maintains one. There's no reason that you can't. I would not recommend it to you unless you have Kubernetes experience, a skill set in-house, because it is a very different thing. I think that as an Oracle database administrator, it's one of those things that would be very foreign to you. So you need to understand the Kubernetes infrastructure underneath and be able to manage it. And let me get back to this question, how to create a Docker image from a VM. So I'm assuming, Ahmed, that you're asking if I wanted to create a Docker image from an existing database on a virtual machine. What I would probably do in that case would be to run, there is a script in your Oracle Home. It's called like clone DB home, something like that. And what that will do is create a copy of your existing database home, and then use that as your install media. So where we were going through and taking the zip file, the Linux install zip file, and using that, because all that 19C and 21C Linux zip file is, all that is a file structure, a directory structure that we unzip and drop onto a particular directory path on our system. So if you were to do that with the directory structure from your VM, then you would be doing the same thing. You would just be dropping whatever that custom VM or that custom directory structure was for your VM. I hope that answered your question. Again, if anyone has extra questions, or if I didn't explain something thoroughly or asked you to reach out to me privately, please feel free to drop me an email. I'm more than happy to talk Docker and Oracle. It's kind of a joke among my coworkers that that's what I do. But yeah, absolutely. Shoot me an email. Feel free to drop by the blog and download the example of a free chapter, again, on persistence that will hopefully address some of those persistence questions. I apologize for going over. I did finish on time as far as the presentation went. It was the questions that took me over. So I appreciate everyone's questions and all your patience and sticking around afterward. If there are no other questions, I will turn this back to Monica and Coleman. Sorry for running into your running late for you guys.
It's great. I love it. Everyone, great job asking questions. I love it when people get involved and take advantage of this time, because this is why we do it, right? We want to get speakers like Sean in front of you guys. So if you've got any recommendations for future topics that you guys are interested in, let me and Coleman know, because this is obviously something people have probably been waiting for. There are not many Oracle on Docker presentations out there. So this is great. But thank you so much, Sean. Thank you, NYOUG. We will get all of this uploaded both to the NYOUG site and to AuraPub, and send you guys an email when it's all ready. Sean will get a slide deck from you guys, and you guys will have a recording, so you can always reference back to this. There's Coleman. Thank you guys so much, and I'm glad so many of you could stay over the hour. So awesome. Great content, Sean.
Thank you.
Thank you
Thanks,
so much.
everybody.
Thank you, everybody.
Take care.